Hello everyone, welcome to our lesson. We're going to continue with our lesson on Euclidean geometry, and in this lesson we're going to look at the corollaries of the theorem which says angles in the same segment are equal. Kindly subscribe to our channel. Okay, let's start our lesson. So we talked about this in the previous lesson. We said that an arc or chord of a circle subtends what? An arc or chord of a circle subtends equal angles at the circumference of the circle. Like here we have the arc PQ, or we have a chord PQ. You see that? So these two, they subtend an angle S there by the circumference and angle R by the circumference. So meaning that angle S is equal to angle R because these are what? Angle S is equal to angle R because these are angles in the same segment. You write that as a reason. Okay. Right, now let's look at the corollaries for this theorem. Right, what is a corollary? It's a theorem that is connected or based on another theorem. Okay, so we have these following corollaries. I want us to discuss them. Right, equal chords subtend equal angles at the circumference of the circle. So we're saying equal chords subtend what? Equal angles. Where? At the circumference of the circle. Equal chords subtend equal angles at the circumference of the circle. So like here, ED is equals to DC. So they're subtending A and B there, meaning that A and B are equal. So angle A is equals to angle B because they are subtended what? By the same, equal chords. So the reason we write, we say equal chords, equal angles. Okay, right. Even this one here, which says that equal chords subtend equal angles where at the center. Equal chords subtend equal angles where at the center of the circle. So we have equal chords AB and DC. These are equal. They are subtending these angles at the center here. So let's say we have our, let me name these angles here. So let's say we have angle 1 here, angle 2, angle 3, angle 4. And then this is all the center. So we can say that angle 1, O1, angle O1 is equals to angle O3. Okay, because of what? Because of its equal chords, equal angles. They're subtended by equal chords at the center of the circle. Okay, right. What does the next one say? Let's go to the next one. This one says equal chords in equal circles subtend equal angles at the circumference of the circles. Okay, equal chords in equal circles subtend equal angles at the circumference of the circle. So we have chord ED and chord BDC. Chord ED subtends angle A at the circumference, and chord DC subtends angle B at the circumference. So angle A is equal to angle B, angle A is equal to angle B, because these are what? Equal circles, equal chords, equal angles. That's the reason you write. Okay. And then the last one before we go to the activity, it says equal chords in equal circles. Equal chords in equal circles subtend equal angles at the center of the circle. Like we've chord AD and chord DC, and then they're subtending these angles at the center of the circle. So angle O there for the first circle and only O for the second circle. Let me just name them and say this is angle O. Okay, we can name them like this and say angle A O D is equal to angle D O C. Right. Why are they equal? Because you say equal circles, equal chords, equal angles. Okay. Right. I want you to try this activity. Just take some few minutes, maybe 2 minutes, and try to answer this question. Let's try. Let's do this one together. So we said that we have our chords here, which is AB. Do you see chord AB? we have chord AB and chord BC. And then these chords are equal, so it means they are subtending equal angles at the circumference. So we can say now angle E, you see angle E, right, is equals to angle D. Okay, these angles are equal. Why are they equal? These are equal chords, and then what? Equal angles. Equal chords, equal angles. Okay, right. So that's why angle E is equal to angle D, and then therefore we can say that X is equals to 20 degrees. That's done. Okay, done. Now let's move on to the next part. The next question, read through the information and then you find the value of X. Let's try that for 5 minutes. Right, welcome back. I hope you managed to try here. Right, what are we given here? We can see equal chords AB and DC. So it means these equal chords, they subtend equal angles at the circumference or at the center, but we don't have the center in this case. So it means it's going to be angle A2 there subtended by angle DC, angle A2 subtended by chord DC. So we can say angle A2 is equals to angle D1. Why are they equal? Why are these two angles equal? Because equal chords, equal angles. Equal chords, equal angles. So now it means this angle A2 is equal to X. But now if you check, we have a triangle here. We remember we want to find X. So we have triangle. In triangle AMD. In triangle AMD, we can see that we have the interior angle there, which is A2 plus M1, angle M1, and then plus angle D1. Okay, these are equals to 180 degrees. Why? This is angle sum in triangle, right? And then now we can find what our X is, because A2 is X, so it's X plus 42 degrees plus X is equals to 180 degrees. And then 2X, and then what is 180 degrees minus 42 is 138 degrees, so it's 138 degrees. And then we divide both sides by 2, we get that X is equals to 69 degrees. Done. We've managed to find the value of X. Okay. Right, now let's do the last one. I'm going to show you the last question, then you do it, then we discuss after that. Let's try. Let's do it together. Two equal circles are given. O is the center of circle, FCD and Q is the center of circle ABE. Determine the value of X. So these two circles are equal. Okay, what do we know about equal circles and equal chords? This okay, equal chords in equal circles subtend what? Equal angles at the circumferences. Okay, right now, so we have angle F1. What can you say about angle F1 here? Let me show you this one. Angle O there is 110 degrees. So what will be angle F1? Angle F1 is going to be 55 degrees. F1 is equal to 55 degrees. Why? Because angle at center equals, how did I write my center here? Right, angle at center, okay, equals 2 times angle at circumference. Okay, angle at center equals 2 times angle at circumference. So this angle F1 here is what? Is 55 degrees. Right, we have equal circles, equal chords. So now we have this chord DC and chord AB. They are subtending equal angles at their circumference. So meaning that this angle X here is also 55 degrees. So we can say that angle X is equals to 55 degrees. Y, we say equal circles, right? Equal chords, okay, equal angles. Done. Okay, we have answered all the questions, so that's what we wanted to know. Right, we're going to continue with our lesson. Kindly subscribe to our channel. Right, and remember, you can see our lessons in the playlist. In the playlist, lessons are well arranged. You can just have your lesson from lesson 1, and you can have that nice and neat progression from one lesson to the other. So you can go to the playlist there and have your lesson 1, lesson 2, lesson 3, lesson 4, like that. They are well arranged in the playlist. Okay, please don't forget to subscribe to our channel. Let's meet in our next lesson. Goodbye.